G'day again, back for more integration. So this is integration 3. Now I've put up 2 examples to start with, and they're very straightforward examples. I want to just do these to start with. This is going to integrate to become tan to the minus 1. This will integrate to become sine to the minus 1. If you put a negative there, that would obviously be cos to the minus 1. So let's just do these straightforward ones. So this is a constant, so let's throw that out the front. You would have 3 integrate 1 over 1 plus x squared dx, and now this is directly off your formula sheet. That's your x squared, that's a squared, which in this case is 1, so that will become 3 tan to the minus 1. There would be something on a there, but in this case it's 1 x on a, and it's just 1. So that's pretty simple. Plus c, very straightforward. Okay, so you should be used to that. This one, sine to the minus 1, again straightforward. This is 4 squared, so it's very easy to fit into the formula. So this will be sine to the minus 1 x on a, and we've got this is a squared, so that's 4 plus c. So very straightforward. You should have those no problem. I'm going to make them a little bit harder because I think at this level it's unlikely that you're to get something this simple without some sort of little trick, because as you get higher in maths, it's unusual for them to give something straightforward unless it's like the first few multiple choice. So let's make them a little bit more difficult. We'll still leave them as tan and sine to the minus 1, and we'll just change, I'll rub that out so we're not looking at it as much. Get rid of that. So let's change this to a 3. Now it's got a bit of a trick. Now you start thinking, hang on, that's not a square. It's not 4, it's not 9 or 16 or something that you recognise that you can put in your A. But it's something you should be able to use, okay? Because it's still a squared plus x squared. And you've just got to realise that is the same as 1 over root 3 squared plus x squared dx. And now, oh look at that. There's an A, there's an x, and you can solve it. It's pretty straightforward, isn't it? You can now go 1 over root 3 tan to the minus 1 x over root 3 plus c. So from there to there is very simple. Looking at it there is the trick. Is looking at it and thinking, hang on, I can still make this a tan. Let's look at sine. So in this case, let's make it a number that you're not used to, so 10. So they put that in and you think, oh, that doesn't work. Maybe I should put a 10 up here or do something, divide by 10. But no, it's still a straight sine. It's just that that is root 10 squared. So you can still get sine to the minus 1. So it'll still equal sine to the minus 1, x on a, and in this case a is root 10, plus c. And that's the sort of thing you need to start thinking at this level where they make things a little bit more difficult. Let's make another change, and we'll just put this on. If we we'll leave that as 3, and we put root 3 up the top. Now this one's going to stay the same. I'll rub that out so we're not looking at that as much. We'll just look at this one. If you did this, root 3 comes out the front, and we just do what we just did just then, 3 plus x squared, and we'll make this root 3 squared dx, and now we've got tan to the minus 1. So we can say this equals root 3, 1 over root 3, tan to the minus 1, x over root 3 plus c. Root 3 and 1 over 3 will cancel, and we'll just get this, so we'll end up with tan to the minus 1 x over root 3 plus c. Okay, now that's the sort of thing you need to look at. We'll do a few more in a minute. G'day, back again for part 2. So I've created this trickier example, which is integral to become a sine to the minus 1, and if you just look at it, again I would move the 3 out here so you can ignore it to start with. So you would have 3 integrate 1 over square root 1 minus x squared over 9. And now it's not actually in the right form. So what you need to do is multiply this by 9. But if you multiply this by 9, you should multiply this by 9, and you should multiply this by 9, right? Wrong. Because this is in the square root, you're actually multiplying this and this by 3. So in that case, you should multiply the top by 3 as well. I should put my dx in there. So if you multiply top and bottom by 3, you haven't changed anything. Okay, and that's something just to be careful of when you see an example like this. They usually put it into a square root, because if they put it into a tan example, you know, so they want you to integrate 1 over, 1 minus x squared on 9, it's really easy then for you to go, oh, that's easy, multiply by 9, 9, 9, and no problem, I still get my tan, I can move the 9 out the front, and it's not really a big deal. Here, it's much more of a mental big deal when you say, that's by 9, that's by 9, this is by 3. Particularly when there's a 3 on top that you think, hang on, I might need the 3 on the bottom to cancel. So seeing an example like this, hopefully, is very helpful. So let's multiply this by 3, which is the square root of 9, and we will get, so I'm multiplying top and bottom by 3. So 3, the 3 stays out the front, square root 9 minus x squared. And now we've multiplied that by 3, that by 3, and that by 3. I'll put my dx in, and now we can do it. And again, I've got another constant, so there's going to be 9 out the front. So we're going to have 9 1 over, so 9 integral 1 over square root 9 minus x squared dx. And now it's straightforward, it's very easy to see the sign, because this, we rub that out and write 3 squared, it's very obvious. It's going to be 9 sine of the minus 1 x on 3 plus c. And you're done. G'day again, back for part 3. So even though it's integration, we're going to do integration in reverse, which is differentiation. Just want to show you a few tricks at higher level that you should look for. If you get something like this, it's pretty obvious what it is. 1 over a, x over a, so it's pretty obvious what you're going to get is you're going to get, well, if you would integrate in reverse, you would get 1 over, if that's a, then a squared is 16 plus x squared. Okay, so if you differentiate that, you're going to get back to that sort of thing. A little trick that is usually tried with this sort of thing is just do that. And then the student looks at this and does faces two problems. They go, okay, well that's a, so I'm going to go 1 over a squared, which is 4 squared, plus x squared. A little trick is because that's a squared, sometimes a student can think, well that's 2 squared, this should be 2 squared, so they leave the 4 there. Just be careful of that. This is a, and this is a squared. Okay, so this is still 4 squared or 16. The only problem is that isn't that, because you're missing the 1 over 4. So what should you do? Put it in. So instead of differentiating that, differentiate 1 over 4 tan minus 1 x over 4 and put that in. Now you've changed the question, which you can't do, but because you've just multiplied by a constant, multiply by another constant and say, well, okay, I'm going to do this multiplied by that. So then your answer will be 4 multiplied by 1 over 16 plus x squared, and the 4 will just go up the top. Okay, so just a little trick there, that it's no big deal to move constants around outside. Let's look at this one. Now this one, you're still looking for the same thing. I've picked on tan and minus 1. You're still looking for the same thing. You want 1 on a, x on a, and you look at this and you go, hang on, that's not 1 on a, but yes it is. And you've done it before, because if this is root 2 on 2, you want 1 on root 2, well this is the same thing. You've actually got it staring you right in the face. Because what have you done before? You've rationalised the denominator. So let's rationalise the denominator of 1 over root 2. What do? You multiply by root 2 over root 2. And you get root 2 over root 2 times 2. Root 2 is 2. So that is the same as that. So this is exactly the same as that. And if you're differentiating that, it's very straightforward because that's your a. So you'll get 1 over a squared, root 2 times root 2 is 2 plus x squared. Nice trick, and you're done.